So next we talk about the environmental effects of air pollutants. As you've seen just now in the previous lecture, the sulfur and nitrogen emissions react with oxygen and water to form the acid rain and snow. And the acid that's formed also decreases the plant's ability to take up the needed nutrients because of a change in pH. When you have too much of the H plus concentration here, cations exchange is affected, right? And this decrease the availability and ability for the plants to grow and thrive. So the falling acid rain and the snow will also acidify the soil, reducing this aluminum, the Al3 plus, that normally will stay sequestered, right, trapped. So this aluminum is taken up by the plants, right, and it's toxic, and too much of it will just kill the plant. So if you are into botany, right, if you grow bamboo will causes the soil to become a bit acidic. It will kill other plants beside. So they are not very friendly towards other plants here. Anyway, acid depositions, right, can acidify not just the plants, the soil around, but also the lakes here because of leaching and harming the aquatic life. Right, so it's the regional kind of effect, not just localized. And then of course, eggs, the animals in the larva stage, right, and the young ones are the most vulnerable, right? So dead lakes are lakes that's with little or no life. So these are often the first sign that the acidification has reached harmful levels, and in dying forests may soon follow. So it always starts from a problem, right? You observe, oh, how come the water bodies is that there's not much life here, right? Because some effects has happened and it was just spill over to the land, the terrestrial forest. Because you need to maintain the ecosystem for everybody to survive here. So trees at the very high elevations, right, they stay shrouded in fog, right? If they are always in fog, they don't really get much of the light here for photosynthesis, right? So if they much of these high rising trees, if they are shrouded, right, covered in fogs for much of the year, right, they are much more affected than others, right? Because all these acidic fogs, right, it's not just blocking the light, it's about being surrounded. Just imagine you're a human that you're always surrounded by fog, by acidic gases, by PM weapon, keep on choking and choking. So plants is similar. By this prolonged exposure to the fog, it does cause a high damage to rainforests, right? Coupled with the acid rain, that also causes the damage to the cultural heritage sites due to the acid-base reaction. We have calcium carbonate, Cacao-3, CaCO3 here, found in the famous example of Taj Mahal in India, in Delhi. Acid rain forms the calcium salt, right, releasing CO2, have some cavity and holes here. So these limestones and marble, right, presents that in statue, they just get corroded, okay, by the acid rain here. Other things such as sandstone, like feldspars and quartz, they can also react with the acid rain, and we have some mini cavities there. So now let's look at example regarding a change in pH in the rainwater in Germany. So this example in Germany. So there was this successful increase of rainwater of pH, right, from 4.3 in 1983, before I was born, to pH 5.2. Now in the year 2009, that's about 26 years later, we are able to increase the pH, right, raise it towards more neutrality. How did it happen? Because there was a reduction in the industrial emissions because of the government policy change, right? Clamping on the where they could put the factories, how much they can emit, putting fines, incentive to push these factories to other locations so that it's all balanced out. So there was a reduction in the brown coal use. They still burn coals for the factories that remains, but they did not use so much of the brown coal, which contains a high amount of sulfur. They use more black coal here, right? And of course, with technology improvement here, there's also this catalytic technology, because catalysts, the sites, right, where you have, let's say, this platinum or nickel here, sulfur just clog it because metal forms a very strong bond with sulfur. So you can't use a catalyst without eradicating sulfur from there. Okay, you just kill the catalyst. Read more about this in the other chemistry module. So the sulfur dioxide emissions dynamics, right, is affected, and then the SO2 emissions increase dramatically as a part of this industrial revolution. Okay. So in the industrial world, particularly in Europe, they are very concerned about climate change, about regulations here. They have done their lessons, not just in Germany, but France and other areas as well. But what about in Asia here? What about in the north? The big country in the north here, right? There's a global decline in sulfur dioxide emissions over the past decade because of stronger advocates. We have more lobbying, to even protest in the Copenhagen summit some years ago here. Then people want to be, they want to address the issues that's affecting the world. Nobody want to be the bad person, a bad country to just say, okay, we don't care about what's happening around the world. We are big and then just do what we like. So therefore, countries such as China has started to enforce stricter emission limits, right? And also the gas desulfurization for the power plants. So you call it the flue gas desulfurization, FGD. Okay. There's also a worrying rise that in India, because we have more populations, right? You have more people means you consume more, you need more energy in burning. Burning of what? Burning of fossil fuels and also organic matters. So when you think about how the socio-economic status of a country here, the populations, right, the size of the country, the technology development of a country does affect pollutions. Okay, give some thoughts to it, right? This is open-ended. I want you to just give thoughts and write something, okay, with research. So that brings us to the end of the 4 portions on the outdoor pollutions. And next part, we will talk about control measures.